Section 6.1, Graphing Systems of Equations. Our essential question today is, do all systems of equations have one solution? We have two new vocab words. The first one is systems of equations, and the second one is solution to a system of equations. Well, a system of equation, system just means that you have more than one equation. So systems of equations have more than one equation. The solution to a system of equations is the point or points in which all of your equations intersect. So, because we're focused on graphing today, I am going to say the solution to a system of equations is where the lines intersect. So that means an ordered pair with an x and y coordinate. Okay, our first example. Graph the system of equations and then answer a couple of questions about the system. What kind of lines are formed and how many solutions does this system have? So my first equation is y equals x minus 2. To graph this line, it's already written in slope-intercept form. So remember, when y equals mx plus b, m represents the slope of the line, and b represents the y-intercept. Our starting point for graphing is always our y-intercept. So our y-intercept is -2. So I'm graphing -2 on the y-axis. And then my slope is 1, or 1 over 1. When you don't see a coefficient number in front of the x, remember it doesn't mean 0, it means 1. So from my intercept, I'm going to use my slope, go up 1 over 1 to the right, up 1 over 1, and then keep going. Because I'm looking for where these lines intersect, I'm going to extend my line in both directions to make sure that I'm giving myself enough points to find the intersection, if they do intersect. Okay, the second equation is not in slope-intercept form, so I need to do some rewriting on this one to get the y by itself. So I will subtract 2x on both sides. 3y equals -2x plus 9. Remember, those are not like terms. And then divide everything by 3. So y equals -2/3 x plus 9 divided by 3 is 3. So this line, I'll graph in red. This one has an intercept of 3. So I start out at 3 on the y-axis. And then I go down 2 over 3, and I see that they intersect. So I don't need as many points on this line. Okay, so what kind of lines are formed? Well, these lines cross each other, so these are called intersecting lines. And then how many solutions does it have? It has one solution. Intersecting lines cross once, one solution, and that solution is the point right here, so it is 3, 1. So they intersect at 3, 1. So intersecting lines means that the lines cross. They cross once, so that gives us one solution, and then I have to name that solution as an ordered pair. The point where they cross is 3, 1. If I substituted 3 for x and 1 for y in each of these equations, it would be a solution. It would be a solution to each one. The equation would be balanced. Okay, second example. My first line is ready to graph. That one's blue. Start at 1, and I go up 2 over 1, or reverse it. And then I can draw my line. That wasn't a very straight line. Okay, my second one, 4x minus 2y equals 6, needs some solving. Subtract 4x on both sides. So negative 2y equals negative 4x plus 6. And then divide everything by negative 2. So y equals negative 4 divided by negative 2 is 2, and 6 divided by negative 2 is negative 3. So my new line has an intercept of negative 3, and then it has a slope of 2 over 1. So I go up 2 over 1, and I draw my line. And these lines are called parallel. So, how many solutions does the system have? Well, a solution would be where the lines cross. These lines don't cross, so parallel lines, no solution. Okay, so we've seen two things happen so far. We had a set of intersecting lines with one solution, and then we named the solution. Now we have parallel lines, and they don't cross, so there's no solution. There's one more thing that can happen. This one I can graph right away, start at negative 3, and go down 2 over 1. Reverse it, and draw my line. Okay, then my second equation needs solving again. Remember, anytime your equation is not in slope-intercept form, you need to do the rewriting first. So subtract 6x on both sides. 3y equals negative 6x minus 9, and then divide everything by 3. So y equals negative 2x minus 3. So, if I start at negative 3, right here, and I go down 2 over 1, down 2 over 1 again, look what happens. I have the exact same line. So these lines, when they're exactly the same, these are called identical. They did not look identical at the beginning because one of them was written in slope-intercept form and the other was written in standard form. So they didn't look the same. But once you solve to put in slope-intercept form, you see that they are. Now because they're identical, how many solutions does this system have? Well, they cross at all of these points. Like every single point they cross because they're the exact same. So we call that infinitely many solutions. So they're identical lines and they have infinitely many solutions. So that is the third thing that can happen. We can have intersecting lines with one solution where you name it. We can have parallel lines with no solution, and we can have identical lines with infinitely many solutions. So this information right here is very important to put in your notes. So you're definitely going to need to pause this slide and copy down all of the information. Down at the bottom where it says describe the equations, what I want to point out is that whenever the lines are intersecting, that will happen if the slopes are different. So if you write your two equations in slope-intercept form and they have different slopes, they will always cross. For infinitely many, the equations are exactly the same, so that means they have the same slope and the same y-intercept. And then for no solution, the parallel lines, they have the same slope, but they have to have a different intercept. in order to be parallel. So the slope is the same, the intercept is different. If the intercept was the same also, that would make them identical. So describing the equations, that's a way to figure out without even graphing what kind of a system you're working with. Okay, now our last slide says, name two lines that make a system with one solution, no solution, and then infinitely many solutions. So this is maybe a little bit tricky because all of the lines have been graphed for you, and they've got these like little conversation things that tell you what the equations are. So like the green line, here's an equation for it, the red line, and then notice that the blue line has two of these connected to it. So what that means is, when we're looking for how many solutions, we're looking for, how many times they cross. For infinite, when they have to be the exact same line, it's going to be the blue because that one's got two listed. It's got two different equations representing that same line. So I'm going to do the infinite one first, okay? So both of these represent the blue line. That means that those two equations put together would be a system with an infinite number of solutions. Okay, now one solution just means that our lines have to cross. So I'm going to go with, you've got lots of options on this one, I'm going to go with the green line and the red line because I can see that they cross right here. Okay, and then no solution, they have to be parallel. So parallel to me are red and blue. So red is y equals 2x plus 2, and blue, y equals 2x minus 5. So red, blue, so red and blue are parallel. Red and green are one example of intersecting. And then blue is infinite. Okay, you should be able to write a summary now, answering your essential question. Make sure that you use complete sentences and restate the essential question.